In this section, we'll talk about how we can use the results of the exposure assessment as well as our knowledge of the toxicity of the compound to arrive at health risk characterizations and also prioritization for further monitoring and further evaluation. So the IH program prioritization depends on the risk ranking that is a function of exposure, the toxicity, and the uncertainty in both exposure as well as toxicity. And then prioritization depends on the program needs, and of course, it's dependent on resource limitations. So this is a schematic of how we can look at health risk, which is a function of both exposure and toxicity. Here we have in this conceptual graph toxicity along the horizontal axis, exposure along the vertical axis. So if both exposure and toxicity are low, then that particular agent poses a low health risk. And as we increase both exposure and toxicity as we go through these different shades of color to the red at the very top right corner, where both exposure and toxicity are high, and therefore the health risk is high. And we can use this idea in a more practical way in a particular organization where we can look at the chemicals as well as the exposure profiles in different departments in a company. And say, for example, that the workers in Department C have a higher health risk because they are more towards the top right-hand corner than workers in Department B who are more towards the lower left-hand side of this exposure toxicity continuum. We can also use this to compare different processes within a company. So, for example, adding solvents leads to a much greater health risk than weighing some components or charging components into a mixing chamber. We can dig in a little bit deeper and make our health risk rating semi-quantitative. So our exposure rating, as we know from the AIJ model, is that we end up putting workers into one of four categories that are defined in terms of the 95th percentile being in one of the four exposure categories. And we can rate them as 1, 2, 3, and 4 along the horizontal axis. And we could similarly look at the health effects and rank them from 1 through 4, 1 being least toxic and 4 being the most. And the table here shows the health risk being a product of the health effect rating and the exposure rating. And so if the exposure rating is 3 and the health effect rating is 2, then we end up with a health risk rating of 6. Similarly, if we have exposure rating of 4 and a health risk rating of 4, we have a health risk rating of 16. So that's the most health risk, and it is also the darkest shading, whereas the least health risk has the lightest shading and corresponds to a rating of 1 in this case. We can add another feature to our health risk grid by including our assessment of the uncertainty in both exposure as well as health effects rating. So for each cell in our exposure versus health effects rating, we can add the element of uncertainty. So 0 corresponds to the lowest uncertainty or most certainty, and 2 corresponds to the highest uncertainty, and 1 is the medium. And so within a particular cell, if the exposure is more uncertain, but the health effects are more certain, then we would be moving along the horizontal axis within the uncertainty grid. Whereas conversely, if our health effects is more uncertain, but the exposure is more certain, we'll be moving vertically. And so now for each cell, we have 4 subcells. And again, we multiply this out. So the information gathering priority is a product of the health effect rating, the exposure rating, and the uncertainty rating. And this is shown more clearly in this slide, where we go from numbers which are 0, 1, 2, 4, and 12, all the way up in the top right-hand corner to a rating of 32, which is the most highest exposure, highest uncertainty, as well as highest health effects rating. Those pose the highest health risks because they are high health risks, but also the most uncertain. This table can be presented in a different way, where on the horizontal axis, I'm showing the uncertainty rating with 0, 1, or 2, certain, uncertain, and highly uncertain, and the health risk rating, which goes from 1 all the way up to 16 along the vertical axis. Again, it's the same information, but presented in a different format, where if you have uncertainty rating of 0, then that's along the second column, and the highly uncertain column is on the right-hand side. So now, using this format, we can say that if we look at the second column, which has an uncertainty rating of 0, or there's great certainty, but you have a high health risk rating, then those are the areas in the workplace where you need to implement additional exposure controls. Those are in the red rectangular box, which says control needed. If we have a lower health risk rating, somewhere between 1 through 4, but the uncertainty is either a 1 or a 2, this is where we need to gather more information, because uncertainty is high, but the risk is not necessarily that high. Then if we go to the top right-hand corner, where we have high uncertainty, uncertainty can be 1 or 2, and high health risk rating, anywhere from 8 through 16. So this is where we need to have immediate controls, but also we need to gather more information. So using this health risk rating and the uncertainty rating provides us guidance about what to do next. Do we need immediate controls, or do we need to gather more information in the form of understanding the workplace better and gathering more monitoring data information, or doing more modeling, or doing both at the same time? So on the x-axis, there is an increasing need for information, and on the y-axis, there is an increased need for priority for control.